Good morning, everyone.
Good morning. Just letting everyone get in the room.
Well, while we're waiting for people to arrive, I think most people know that I do saltwater aquariums. And I hope everybody knows what a sea anemone is.
Indeed.
So if you're not aware, sea anemones move around however they want. They don't really stay in one place necessarily. So I recently got some clownfish for it. It was great. I was loving it. And then I woke up one morning to find out that my sea anemone had decided to place itself on the intake to my pump.
Huh.
And I woke up to an aquarium of soup because it got sucked in and chewed up. Not a fun experience. So anybody who's thinking of getting into the hobby, be aware.
Yeah, with fronds like these, who needs anemones? All right. Well, it looks like we've got a good crowd. Let's go ahead and get going. Rao, are you ready?
Yes, I am. So the status of the networks remains the same. We did have an issue this last week where there was a bad disk on one of the machines that brought the mainnet down, but the issue was resolved without any loss of continuity. So that's all about the state of the networks as to what's different or an update on those. The main activity, of course, in terms from a development standpoint, is the leaderless block merge. There was a lot of conversation and detailed design discussions on this. The document is here at the link that I'm posting here. Let me just check to make sure okay. So feel free to go through that. There may be a little bit more additions and detail on that. Tomislav and NetZipper are putting in the final descriptions of it. But this basically clarifies and articulates how the leaderless block merge works. I don't know, Greg, if you wanted to go over this today, or we want to wait until they have the implementation probably to do a review of that, perhaps. In any case, so the team is moving towards coding that, and Tomislav, in terms of helping with the testing of this, because you have a very dynamic DAG and a lot of dependencies changing dynamically, and the conflicts and the fringe, everything is quite dynamic. So what he has done is he's creating a simulation-like testing environment where we can easily analyze the behavior of any kind of network or DAG condition that may arise in the concurrent processing of blocks and messages. So that's actually a very interesting thing. Again, this is something that the kind of tooling we're having to do because of who we are. We are a concurrent DAG. So I think it's a little bit unique in the general blockchain industry. And then Tomislav also has been working with the RChat, working with Martin on the RChat task. I think Martin has his first PR ready to get that going. And NetZipper, even though the description here is different, some of the code was done before, so NetZipper has extracted that and is in the PR now to be merged into the hard fork 2 branch. So that actually is right now trying to resolve some tests on there, some of the failing tests there. Dennis has released his PR for import-export with his improved algorithm for history using the radix tree implementation. So basically it gives better performance and uses reduced storage. I want to briefly kind of show you this is his PR. He's still working on some tests that are failing on this, but please take the time to review his PR. He had already actually gone through these graphs a few weeks ago, if people remember. But it is good to see where, what kind of improvement you should be expecting with this PR. So that's that. And Stas is working on refactoring the hot store code. He has basically, Stas has been taking on quite a few deep dive tasks to give him more familiarity with the code base. So he has been working on different parts of the code base to where there are problems to be solved, but in the process also been getting familiar with how something is done. So right now he's refactoring the hot store code. He has completed this for REPL clients to use 40402 as the default port. That task is done. The PR is waiting for review, I think, right now. And he also has his PR for to parameterize the minimum flow price. That's also waiting for review, and both of those should be merged after the reviews are over. And Will is continuing his work on the POS contract. This is again part of the hard fork too. So I think he's probably a few days from completing that. In terms of the development, that's what I have. And I think we have a demo that Raphael wanted to do using multisig on dappy. Is Raphael here? But before I turn over to Raphael, are there any questions on the development update?
So I asked this before. I guess there are two questions here, and forgive my naivete, this information might be out there for me, but I figure I'd ask here. Do we have a current anticipated hard fork schedule for,
not really, not until we're satisfied with the quality of the LLBM. As soon as that's done, then we can have a more firm schedule. But this is such a major change. We can't roll it out to mainnet unless we know that it's solid.
That makes sense.
Yeah, like I said, I mean, some of what we're doing here is unique in the blockchain industry. So we do want to take the time to make sure that we have the testing and the full dynamics of the concurrent DAG and the moving last finalization and the merging of all those things that is well tested. So there is, we'll probably need some time for that.
So I guess the primary reason for my question was Dan Connolly was talking about the proof of stake contracts and getting rev addresses for smart contracts. There's an art chip out there, I forget which one it is. And he was wondering whether or not that would require being part of a hard fork and whether or not it might fit in with the current ideas.
Yeah, so we're going to be talking with Dan about that in a little bit. I want to make sure I understand his intent, and we also want to probe it for potential security problems. But I mean, provisionally, his proposal seems like it's something that we can add to the next hard fork.
Okay.
Yeah. So, I mean, basically, I think Dan's proposal is to help in some way with taking polls. So this Friday, if folks are available for the tech governance, we will take up that issue of what are the requirements to support staking polls. I think Dan's proposal may be sufficient, or maybe there's more needed, or maybe there's a different way to address that whole thing altogether. So that's the conversation in the tech governance meeting, to have different folks. In particular, there is another party that's interested in being a staking pool provider. So at least we want to capture their requirements also, and then figure out what is the right answer for that. And once we figure out what the right answer is really then what determines, do we have the bandwidth to get some portion of that in the current hard fork, or do we really want to just push it to hard fork 3? I mean, the more we throw into the hard fork 2 deadline, even though something may seem like a small thing, there would still be testing and all that. So at this time, the default answer is, like Greg said, next hard fork. But if there is something that's really tiny that doesn't affect anything else that we're doing, maybe we'll take a look at that to see if it fits in the current
I guess that's where I was, is if this is going to happen, where does it fit in? That was really my question. So,
it's most likely next one.
Yeah. I mean, first we have to determine what it is that needs to be done, because it's not clear to me right now. I know what the ask is, but I'm not sure if that is solving it. So that's why we want to, but that's a legitimate request for to say, what support is needed for supporting staking pools. That's the reason why we want to approach it from that standpoint, to say, let's do at least different parties that are trying to do staking pools, let's get the requirements and then go through the design and see what makes sense from that standpoint.
I understand it does need to be checked for completeness. I agree.
Yeah.
It's issue 32 under our chip proposals, and I assigned you, Rao, and Greg to it.
Sounds good. Sounds good.
Now, I guess the developer of POS may want to be assigned there also, whatever.
Yeah, I mean, we have, like I said, we have another party also that's that has just started work with us to provide staking pools. I invited them, or I asked them if they would be able to participate in the Friday tech governance conversation with the community, and we'll see. We'll get that. We will get that ball moving. So to speak.
Unfortunately, Friday, I don't think I'll be able to be there. I have a doctor's appointment.
Oh, you are?
Yeah.
Okay.
It's also Christmas Eve, right? So.
Oh, this Friday is Christmas. Yeah. So I guess that I should definitely move that to some other time. Then I'll think about the schedule. I completely forgot that we were this close to Christmas for some reason. Sorry about that. So yeah, all right, we will work rework the schedule on that, but we'll certainly we have our eyes on that to get started, and but we will take that up and then figure out where it fits schedule from a delivery standpoint.
So I did want, Rao, before we close out the tech update, I did want to point out, just to sharpen the language. So we've had the merge part of this for quite some time, and what the team has been working on is grasping how finalization and merge interact. So those are two separate features, right? We have a notion of finalization and we have a notion of merge. And the question is, how do finalization and merge fit within each other? And that's what that's the last little bit that they've been working on. And I'm quite pleased with the progress that they've got. They've got sort of the core algorithm, and now they're expanding that core to allow for more fault tolerance within the network. That's really what's going on. But there's a piece of the puzzle that is quite interesting, and is maybe of interest to the general community. So I'm just going to screen share really briefly, and I just want to show one little thing so that people understand what's kind of cool about this. So here's a simple DAG. So you have validators A through E, and we're counting the levels here in one base counting as opposed to zero base counting. So this is A1, this is A2, this is C3, this is E4. So people can follow along as I'm calling out the battleship moves or the chess moves, depending on how you think about it. Now the notation that we've got here, these dark borders here, indicate that this is the latest sort of finalization fringe. And you can think of this as a barrier. It blocks prior to this barrier can safely be forgotten because using the protocol, we know that we have a proof that everyone is at the same state. But we don't need to remember how we got to that state. We only need to remember that everyone is in fact at that state. And now what we're looking for is the next fringe, the next sort of layer or boundary where we can forget stuff. And what's interesting is you can imagine that maybe A, C, and E are moving more rapidly, or that they are closer to each other network-wise. So they're seeing more of each other's blocks. So you could think of that as a kind of a temporary partition of the network. And these lines here represent the justifications. So in the Casper protocol, sort of what makes the Casper protocol tick is that blocks say which other blocks they have seen immediately. In other words, what blocks justify the production of this block. And in this network, what we can see is that A3, C3, and E3 give enough stake to A2, C2, and E2 that that they can't be rolled back. Now that doesn't give you the whole row across, which is and it's important to have the entire shard ultimately in agreement if you're going to advance the shard's state. However, what is interesting is that it is not until this point at A4 that A sees that there is enough stake behind A2, C2, and E2 that they cannot be rolled back, that they are effectively final. And so you can see this as a point of knowledge, right? At this point, A knows that these three blocks are final. And you can imagine that if this C4, or sorry, if you can imagine that if you had enough, like a block here, like a D4 or a B4, that put a similar stake, a similar kind of staking pattern, then between the A4 and the B4, you would have enough to cover the whole row. So you would get finalization of the state of the entire shard. And if you have enough stake on top of, say, A4 and B4, so you have, say, 2/3 of the stake on A4 and B4, then at that point, then you know that the entire that this entire barrier is final. But what's interesting, and again, I want to emphasize this, is that at the point where you have A4 published, the validator, knows something about the DAG with certainty. A knows that there's enough information that within its purview, within what it can see, that A2, C2, and E2 are not going to be rolled back. When you add in say the B4 with a similar kind of network structure or DAG structure, you'll have that B knows that. So then you have A and B knows that. And if you have 2/3 of the stake above them, then you say that the network knows that these three cannot be rolled back. So these points of knowledge are important. It says that the network can talk about itself and talk about what it knows. So we can have statements about what when a particular individual validator knows. And in fact, we can have statements about when a partition of the network knows something, knows a property. And we can talk about when the entire network knows something. So I would suggest that you think about this and compare it to machine learning algorithms, and their notion of when a network has been trained and what a network can recognize. Here we have the network capable of reasoning about itself and making statements about itself. So there's a kind of reflective capability that is available to this version of CBC Casper that is of note and of interest. In particular, because the state is something that is evolving, and the state reflects a representation of an external environment as well as an internal environment. So the state builds up information about sort of an interaction between the outside world and the network. And so you can talk about the network learning about the outside world as well as learning about itself. And because of that, this represents a really interesting variant of machine learning kinds of capabilities. Any questions about that? All right, I can see everyone is particularly excited about this.
I mean, that is really good. I mean, it's implied machine learning, or the network basically moving forward using implied machine learning is really what we're talking about.
Yeah, but it's different in the sense that it's not black box. You don't the weights on the links have a different meaning than the weights in a convolutional neural network.
Yeah, so I was going to comment that neural networks tend to reach at some point a steady state. Even if it is continuing to learn, it's not learning as much later as it is at the beginning.
Correct.
And this seems to be that it's always learning about itself, so that it doesn't reach that quote unquote steady state that I'm referring to. Am I correct in that?
Yeah, so it reaches so the notion of steady state is the finalization fringe. So
Right.
So at this point it's learned something, and this is never going to go away in this how do I say this? I mean, it is able to forget this once it's got the next fringe, but this is a point of stability. You know, it's as if it's acquired this view of the state of the system. And then when you get the next finalization fringe, that's the updated view. So it can know things both about the network and about the this interaction with the external world. So this is quite different. It has a lot of different features from traditional neural networks, but we can imagine alternatives, for example, in which staking is more dynamic, that would bring it closer to traditional neural networks, but still retain some of these interesting features. I think neural networks, for example, are not traditionally, I mean, in fact, I know of no papers in which you have the network introspect on itself. Whereas this thing definitely introspects.
Wouldn't this be closer to virtual voting?
It's sort of like virtual voting, but it's also different than virtual voting. Because you need, like, for example, if you think about rounds of votes, then it isn't until the fourth round of voting that you know something about the second round. So that's fairly distinct, right? I mean, with virtual voting, the kind of the point is that the outcome is for you know an outcome immediately, whereas here you need information from the future to guarantee results about the past.
So it's a step beyond virtual voting, yes.
Yeah, one or
It's
two
like-
steps maybe. Yeah. All right. Well, thank you for your patience. Let's move on then. We have a few other things to talk about.
We have a demo from Raphael.
Yes, Raphael, I was about to hand it over to you. Raphael, are you ready?
So yeah, I have two things to talk about. So I'm Raphael, the lead dev of the dappy project. Dappy is a secure web browser and name system on RChain. And today we did our third live session on dappy. So basically we asked some users to download the browser. Now you can download right from the homepage. And yeah, we did some NFT minting and token exchange. So the video is already on YouTube. You can check it. We were around 30 on VooV meetings plus Zoom. So it went very well. It was on the classic testnet. And yeah, everything was fine. So yeah, that's it. You may just want to check YouTube for the video. It has been shared on the members channel as well on Discord. So it was this morning or end of day, but yeah, it was at 1 p.m. Paris and 7 a.m. New York. So yeah, that's it for the first item. And the second one is to do a demo of the multisig wallet that I have worked on. So I have worked on it in a live coding fashion. So in the end, there are 9 parts that will be uploaded on YouTube. Right now, you have already 5 that you can watch. And the code has not been published yet, but it will be shortly on GitHub. So I'll go to my presentation. So multisig means multi-signature. It is a smart contract that is managed by multiple identities or private keys instead of a single one. So the obvious case is to control some rev, some cryptocurrency, but you can also do some other kind of operations with a multisig. And yeah, this project has been built in anticipation to handling RChain token operations as well. And what it means, yeah, in few dappy documents, we talk about domain names that could be managed by multiple identities. So multisig has been built in anticipation for such a feature and other features as well. So for example, so you have few settings in a multisig smart contract. One, we could call it synchrony constraint. And by default, it is at 66%. So what it means that for an operation to occur, we need at least 66% of the members of a multisig to agree on those operations. So in the case you are only 2 in the multisig, you need everyone to agree, so 2 out of 2. In the case you are 3, you need 2 out of 3, etc. And in the case you are 50, you need 33 out of the 50 identities in the multisig to agree on a batch of operations. So this multisig has a feature that I'm not sure other multisigs have, and it is to handle by default batch of operations, list of operations instead of single operation. So when you use this multisig, you don't propose just one ref transfer. You can propose 60, and other members will have to agree on those 60 same ref transfers for them to occur. So right now we just deal with ref transfers, but as I said, the goal is to handle RChain token actions and also other kind of actions as well in the future. It is based on object capabilities, and it has been built. If you watch the videos, you'll see that at the same time that I write the Rowlang, I also do the command line interface and the SDKs for Node.js. So yeah, I have few steps to go through for the demo. So we'll do a very simple multisig that has just 2 public keys. So first thing, yeah, I have followed this tutorial and I have my local R node running on my computer. So it is ready to receive deploys. Now let's get straight to the code. So the first step will be to deploy a multisig and to set the public keys for this multisig. So in our case, we will have 2. So the command is node CLI deploy multisig. And then you give it a list of public keys that are comma separated. So let's use this one and this one. So this, okay. So I have a previous registry URI in my AMP file. Let's try again. So it's been deployed, and now let's wait just a few seconds. Okay, cool. So I can go very quickly through the methods that are available. One of them is read. It basically tells you the configuration values and some stuff you would want to know about this contract. So I can just do node CLI read. And we can see that, okay, it's a multisig contract. It has 2 public keys in total, but none has been claimed yet. So the object capability has not been activated. And that's the address of the multisig. But careful, it's not the rev address, and the rev address is right here, right below it. So now we have a command that will be used by those 2 identities to recover the object. So it's kind of an initialization thing. So it's node CLI get key. So basically it signs the registry URI, and this is what allows someone to be authenticated. So let's wait. Okay, we have the key that has been recovered, and the second person has to do it as well. So I'm going to change this private key to impersonate the second identity and do the same. Okay, so now now I can do again node CLI read to see what's changed. And what's changed is that now the two public keys are recorded. So the two people are able to interact and send commands to this multisig wallet. So, okay, let me go back to my presentation. I almost forget it. So yeah, that was deploy multisig. Now we can, of course, send a ref to this multisig wallet. This is its only purpose right now. It's to be a decentralized rev like Vault. So I'm going to use this script and send it a very small amount of 10,000 dusts. But yeah, this is not really important. Let's wait. Okay, the transfer is going on. And you can see that the synchrony constraint is at 66%, but you could have 90% or tweak it any way you want. Okay, let's do node CLI read again. Okay, we see that it has 10,000 dusts. So now we're going to start to propose some operations. So one cool thing with this multisig is that you always propose batch of operations. So you can do a single one, but you can also propose like 100 ref transfers. And also later you'll have other kind of operations like NFT purchase, NFT withdraw, some tokens actions. So let's propose this batch of operations as the first identity. So yep, it's the right private key. So I'm going to do node CLI, propose operations, and then I must reference a JSON file. And it's that one that you just saw. So I'm deploying. Let's check the Roland. So you see that I'm proposing this list of operations through object capabilities. So it says operations recorded. So now I can hit 1 second, one other public endpoint of the contract to read the operations for a given public key, just to make sure. So I can do node CLI. I think it's just operations. And the public key is this one. Okay, so it tells me that yeah, 5 operations have been proposed by this public key. Of course, they only reach 50% of the multisig. So no execution has taken place yet. And now, of course, so what we can do first is propose different operations. So we're going just to change one letter. And the second public key will propose those operations. So yeah, it told us operations recorded did not execute. So yeah, that's right. So let's do again, propose operations. Okay, we should have the same result, did not execute. And of course, this is correct because the operations were different. So there was no agreement on the operations to execute, but it's fine. It's the purpose of the multisig. So now we're going, the second identity will change his choice and propose exactly the same operations as the first identity. Let's do again. Okay, and now we have operations recorded, did execute. So this proposal triggered the executions of the transactions. So we can just do a node CLI read to get some information. We see that the balance has been decreased. So it's a good sign of transfers having been executed. And as you can see, one transfer is too big to have been executed because the multisig only has 10,000. So we should have just two transfers that have occurred, and the other ones should have failed because of incorrect addresses or insufficient fund. So in multisig, there is a third public endpoint. So anyone can see the last batch of operations that were proposed. So let's do node CLI, last operations. Okay, so we have a result of each operations. So the first two ones were successful. The latter three failed. So yeah, that's our predictions. And of course, when some operations are triggered, they are reset. So now if I do node, if I try to read again the operations of a public key, yeah, I get no operations because yeah, we would not want someone to be able to like propose the same operations 3 times and be able to trigger 3 times. So when a set of operations are triggered, for each public key that is concerned, it's reset to nil. So I think that's it. Let me check. Okay, propose different operations, propose same operations. So that's what we did. So yeah, I'll upload on GitHub soon the source code, and yeah, on YouTube, the 9 parts will be uploaded soon as well. So yeah, I think that's it. So we have our 2 public keys multisig that is working and deployed. So feel free to ask questions or to yeah, or not to.
That's very nice, Raphael. Very nice.
Yeah. No, looks good.
That was really nice stuff, Raphael. I have a question. Is this still only Node.js? Is there an interface here other than Node.js?
So right now, no, but you can. So the way I develop is that I build the Roland files, and then there is a code generation step that turns them into JavaScript functions. But if you want to build, let's say, Python or Rust, like CLI, you have very few things to do, and you just have to take those Roland files and do the proper interpolations. Everything you can do with this contract is in the Roland folder.
Okay, I think I understand. Raphael, I would love to spend some time with you in January to talk about this.
Yep, of course, with pleasure.
Very good. Thank you very much, Raphael. Excellent demo.
Yep, thanks.
Moving on. So we have secured additional strategic partnership agreements. I will give the details of that in, I guess, in January, since we don't have the closed door sessions. But yeah, the co-op is continuing to increase the number of partners who are engaging, providing a wide range of services. So that's very good from our perspective. let's see, what else have we got? We had the board meeting. It was largely informational on Tuesday. And I think that just about covers it in terms of business items. I guess Daryl is not with us today. Did Daryl nominate someone to do the week in review? No? Okay.
No.
All right.
Sorry.
All right. No worries. No worries. We'll pick that up again, probably in 2022. Any questions or comments from the community?
This is something that occasionally I return to as a question. I remember in the past, there was discussion of replacing the consensus model, and I was wondering if there was an update on that.
Replacing the consensus model. You mean
Yes.
using different consensus algorithm?
Yeah, so there was a discussion that Casper was going to be moved aside at some point.
Oh, no, very unlikely that it, so what we were discussing was some possibilities for a more optimized, something that where the consensus can happen earlier in the process, but that's that certainly won't happen before Venus, if it happens. As I've tried to indicate, the classical consensus, from my perspective, classical consensus is at its horizon, its zenith. A quantum consensus will overshadow classical consensus in a few short years. So time spent on developing classical consensus algorithms is, again, and this is just my opinion, but it's not going to be very effective because it takes so long to get a consensus algorithm to production ready. So by the time you developed a new consensus algorithm and then you got it production ready, that's kind of on the 10-year horizon. But in the 10 to 15-year horizon, we'll begin to see our first quantum consensus algorithms. And they will so vastly outperform the classical ones that it's not even in the ballpark, right? So that's that's kind of my current take on things.
Okay.
And I think what you're doing now with Casper is you're optimizing. You're using intelligence to do better than Casper, and working toward the quantum in an evolutionary manner.
I mean, what's going on now is just getting the team up to speed on stuff that Vlad and I worked out, 3 years ago. It's just, that was never implemented by the previous incarnations of the dev team. We're just getting people up to speed on stuff that was already worked out a while ago. And kind of lost, a lot of the design rationale was not well recorded, not well documented. And so we're putting together all of that documentation so that the dev team actually understands what it is that we're doing. I mean, most of what's going on is just common sense. By when do you have enough information that that the network has recognized that certain blocks can't be rolled back, right? And it's like this is just common sense. It's like there's a point by which you know this and you can just work it out from the justification structure. And the more subtle things about it have to do with being able to detect when the network is partitioned and what you do about network partitions. And the network partition stuff is actually more interesting because it allows Casper to proceed. You can have lots of little sub networks all working even though they can't see the rest of the network. So they can just keep going and then there's a reconciliation for the subnetworks. But again, that's all just kind of bread and butter classical consensus,
Yeah.
but the quantum consensus is much more interesting. It's a very different world, because you have all these weird non-local correlations. And Casper is certainly not making use of weird non-local correlations. All right, any other questions or comments from the community? Okay, thanks to all. We will have a community debrief in the week between Christmas and New Year's. But in the interim, I wish everyone happy holidays, and please stay safe, stay warm, and we will see you on the other side.